Alright, so in this video we're going to go over some very basic trigonometry. So let's go ahead and get started with the acronym that we use. So, ka, toa. And let's refresh our memory as to what each one of these things mean. The first one, so, is saying sine of an angle. So I'm going to put here x. So again, remember this represents an angle. So I'm going to write that here. The angle goes in that spot where the x is. And we write it inside parentheses. Okay. So it's sine of the angle equals the opposite over the hypotenuse. And right now I'll draw a triangle to kind of show where these sides are. So we'll talk about that. But let me just write the equations. So ka means cosine of the angle, which I'm going to use x here, equals adjacent over hypotenuse. And then we have toa, so that's tangent of the angle, equals opposite over adjacent. Okay, so we have the three basic trig ratios that we're going to be working with. Let's go ahead and draw a triangle so you can go ahead and see what these words mean. Now, the basic trigonometry we're dealing with here only applies to right triangles. When you get to pre-calculus, you're going to learn some other stuff called law of sines and law of cosines, where you can actually use trigonometry to find the sides of any scalene triangle. So, or it doesn't have to be a right triangle. So any triangle, non-right triangles. Okay. Now back to this. Let's go ahead and talk about what these different words mean in the right triangle. So the first thing you need to do is you need to look at a certain angle. So let's say this is the angle x. Once you look at that angle, then we can figure out what these sides are, or what this represents. So the side that is opposite, or on the other side of the x, is obviously what we call the opposite side. Notice I drew an arrow here. Sometimes it's helpful to do that in the beginning. So you can actually, if you want, you can draw like an arrow showing that this side is the one that's on the opposite of the angle x. Now, of course, the one that's right next to it is the one that we call the adjacent here. Now, hold on a bit. You might be saying, wait a minute, this side over here is also next to the angle x. Well, yeah, that is true, but he's a special side, because this is the hypotenuse of the triangle. Remember, the hypotenuse is always the longest side. It's also the side that's on the opposite of the 90-degree angle. And so here's our 90-degree angle, so on the opposite, the hypotenuse. Okay. So sometimes it helps to, if you want to write hypotenuse as the first one when you see a right triangle, that's helpful. So you already know that that's the hypotenuse. And then we have our adjacent, and then the opposite. Now, one very important thing to note immediately is the sides that are opposite and adjacent depend on what angle you're looking at. Suppose I drew another right triangle like this, but I wrote x up here. So if this denoted the angle x, then the opposite is now on this side. So that would be the opposite now. Okay, so that's the opposite. And then the adjacent would be on this side. Alright. So it's important to know, like, when you're solving these problems, make sure you look at the angle that you're working with, right? You want to look at that angle and then establish which side is opposite and which side is adjacent. That's going to make the problems a lot simpler if we can just start off by identifying the appropriate sides and angles as well. Alright? So again, it's always with respect to the angle. Now let's go ahead and let's say we wanted to find, or let's say we wanted to write an equation for, let's do cosine of x. So again, if we had cosine of x, remember this is the angle. This equals adjacent, which would be this guy right here, divided by hypotenuse, which is up here. Okay? Now, look at how it would be over here. This one, it's still the same, right? Like cosine of x is adjacent over hypotenuse. It's still the same on this side. The only difference, though, is what sides we're using, right? The adjacent is now on this side, right? It's not down here like in this other triangle. So again, you always have to be careful. You have to look at the angle that you're working with first. Alright, now we can try some practice problems that we did go over, but I'm including them in the video just to kind of, we did go over these, but let's just kind of work them out again, just to see, you know, if you want to practice them again. So on question 1 we have that triangle ABC is a right triangle, and B is the right angle, right? So B is where the right angle is. So I'll put A up here and then C over here. Okay, now here they're telling us that sine of angle A equals 3 over 5. So this is some important information. They're giving us a ratio. This means that in our triangle, 3 is going to go somewhere on the triangle, and 5 as well, one of the sides. We need to figure out, which sides are we going to write those numbers on. So we have to go back to our acronym, SOHCAHTOA, that's up here, and figure out, well, they're asking sine, so we're going to use SO. That means that sine of the angle equals opposite divided by hypotenuse. So now we can go back, and I'm going to write this. You don't have to write this, but I'll go ahead and do that. It's kind of helpful. It's opposite divided by hypotenuse. Okay. That means that the number on top in the fraction, the numerator, corresponds to the opposite side. Question, opposite side of what? Well, what angle are we looking at here? We're looking at angle A. So where is angle A? Well, if you go to your triangle, angle A is just right here, right? It's where the letter A is, a capital A. So we're looking at the one that's opposite, the side that's opposite to that angle. That's over here, and that is the number 3. So that's where 3 goes. And then, of course, the denominator corresponds to the hypotenuse, which we know is over here, and that's 5. Okay, so fair enough. What's the question asking us to do? It wants to know, or wants us to find, the ratio for tangent of angle C. So, question mark. Well, how do we do that? Well, first we need to look at where angle C is. And I'm going to use this red pen to kind of denote that. So that's right there. Now, if it's tangent of angle C, going back to our SOHCAHTOA, the TOA is what we use for tangent, and it says that tangent of an angle equals opposite divided by adjacent. So that means that this is opposite over adjacent. Okay. And now we need to establish what those are in our triangle. So again, I marked this in red. We're looking at the side that's opposite of angle C. So opposite would be way out here, right? This guy over here. I'll go ahead and write that here, opposite. Again, with respect to angle C. Over the adjacent, so ADJ. So where in the world is adjacent with respect to angle C? Adjacent is this one right here, ADJ. Okay. Now we already know what the adjacent is, right? It's 3. So I'm going to go ahead and maybe write this again over here. Tangent of C equals opposite over adjacent. So we know the adjacent is 3, but we don't know what the opposite is, right? We don't have a number for that. So we need to solve for that. So how do we do that? Well, this is a right triangle, and we can use the Pythagorean theorem. So that would be 3 squared, right? It's one of the legs, plus, let's call this B. So B squared, which is the leg we're looking for, equals the hypotenuse squared, which is 5, so 5 squared. And then now we just simplify our math. This is 9 plus b squared equals 25. Subtract 9 from both sides. You get b squared is equal to 16. Then you take the square root. We're left with b equals 4. Now you might remember in algebra, when you take the square root, you should always have plus or minus, right? Remember that from algebra? The problem here is that this is a geometry context, and we can't have negative numbers for our lengths here. Lengths have to be positive. So that's why when we're doing the Pythagorean theorem, we just disregard that negative 4. So we just only look at the positive, so just b equals 4. So that means that the opposite is 4, which means that this part right here is 4. And that's the ratio. Tangent of c equals 4/3. Alright, so let's go ahead and do one that involves a calculator. So this one is, this one's going to ask us to compute. So now we have to compute one of the sides using trigonometry. So 37, and then over here I'll put a t. Okay. Now, one very important thing, we're gonna, I'll talk about this in a little bit. Let's set up the ratio first, then we can talk about the important thing. So using our SOHCAHTOA to set up our ratio, we first look at this 41 degrees. That's the angle that we're interested in. The side we want to find is, guess what? On the opposite of 41 degrees. So this is the opposite side. And the other number we're given, this guy right here, is the adjacent side. So what that means is that we have to use the ratio, or the trig function, that has opposite and adjacent. And that one goes with TOA. So it's tangent of 41 degrees, in parentheses, equals opposite, which is t, divided by adjacent, which is 37. Now we have to use some algebra to solve this. Since we're trying to solve for t, we need to multiply both sides by 37, and we're left with t equals 37 times tangent of 41 degrees. So now we're ready for the calculator, but we have to be very careful. Notice that the units for our angle are in degrees. Now, there are different units that we use for angles. So the ones that we know, that we've learned since elementary school, are degrees. One that you're going to learn in pre-calculus is radians. So we're not worried about radians right now. That's going to be something you learn in pre-calculus. And there are other units as well. There's also like radians, for example, but that's later if you take other math courses or other application courses. For now, the units we're interested in are the ones that we've always been working with, which are degrees. You might be wondering, why did he start talking about different units for the angle? Well, because when we go to our calculator, let me go ahead and pull it up over here. We have to be very careful with these calculations. Does it look like it's blinking? Okay, no, I thought there was something wrong with it. Okay. We have to be very careful with our calculations. We need to always check by going to the mode. So we're going to do something, we're going to check something. So you click mode, and you go to the, is it the second? Yeah, you go to the third column right here. Sorry, third row. And there it says radians or degrees. They're right next to each other. We always want to make sure that degree is selected. Okay, so we want the little black box around degree. If it's on radian, you're going to get the answers wrong. That's important. The only time they wouldn't be is if the questions themselves had radians as their units, which they won't in high school geometry. They will in pre-calculus, so you're going to have to be more cognizant of that. But for now, in high school geometry, we only pay attention to this. We want it to be in degrees. Now, when you set the mode in degrees, it will remain like that unless somebody messes with it. So if another sibling or somebody starts messing around with a calculator, they could accidentally switch the mode. Or if they clear the memory, I can show you that in a separate video. But you come here to the memory thing, you press 7, blah blah blah, reset. If you reset the memory, it will go back into radians. Okay. So whenever that happens, you just go back down here, go to degree, select it. Alright, good. Anyway, once we know that it's in degree mode, then we can go ahead and plug in our numbers. So 37 times tangent, and then inside we just put 41, close parentheses, and then hit enter. And we get 32.1636093. So we can go ahead and round that to the nearest hundredth if you like, and that would be 32.16. In the choices, I believe they round it to the nearest tenth. Let me check. Yeah, so they rounded to 32.2. Yeah. Alright, so that's how you use the calculator to solve these trig problems. Now, there are like two basic kinds. One of them is when you want to find one of the sides. So they give you the angle, so 41 degrees. They give you one of the sides, and then they want you to find the other side. So in this case, it was the opposite side. The other kind of problem is where we want to solve for the angle. So we have two sides, but then we need to find the angle. So like question 4, for example. In question 4, we have our right triangle. This is 8. This is 17. This is 8 degrees. Here, we don't know what the angle is, but we do know what the side over here is and what the hypotenuse is. So again, we're going to use our SOHCAHTOA to at least set up the ratio. So let's do that. So in this case, we look at our angle A. We look at the side opposite, right, which is over there. So I'm going to write opposite here. And then of course 17 is the hypotenuse. Alright, so now we can go ahead and write it. Which one of our SOHCAHTOA, right, which one of those has opposite and hypotenuse? It's so. So sine of A equals opposite, which is 8, over the hypotenuse, which is 17. Now when you're looking at this, this is actually very interesting, because algebraically we have this A here, so we can't just divide it by A. We can't separate the sign and the parentheses here. This is a function. That's why you learned about functions in Algebra 1. So we can't just separate the sign and the A. This notation goes together. Okay? What that means is that we have to use our inverse functions. And you have them in your notebook. And we're going to write it like this. Now, you don't have to write this exactly the way I'm doing it. I'm just doing it so you can see formally how this works. Remember when we said, like whenever we're solving equations in algebra, what you do to one side, you do to the other side, right? And you always want to use operations that cancel things out. So for sine of A, if you want to cancel that out and just get A, you need to do the inverse operation. In this case, it's the inverse function of sine of A, which is sine inverse. So again, don't freak out with this kind of arcane notation. I'm just writing this to be purely formal. So this sine inverse, we plug in this guy inside, because we're taking this as the argument of the function, right? The part that goes inside the function. So we're writing it like that. Now you don't have to write this. You don't have to write it like this. You can just skip the step. Again, I'm only doing this just to be purely formal. So the sine inverse cancels out the sine, and what you do to one side, you do to the other side. Completely left that out. And that one was 8 over 17. Okay. Of course, we took the inverse sine of the left. We have to take the inverse sine of the right side. Okay. So this whole thing cancels out, and now we just have A equals sine inverse of 8 divided by 17. Once we get to this step, we go ahead and get our calculator. Again, we check that it's in in degrees, right? Make sure it's in degrees. And then we can go ahead and type in this. So you press the second button. Here, let me see so you can see that. You press the second button, and then sine, and then now you get this sine inverse. It's sine with a little -1. And then we plug in 8 divided by 17. Close the parentheses, hit enter, and there is our answer. So we get 28 degrees. Okay. Now, when you're working on this, you can immediately skip from this step straight to this step. You don't have to do this intermediate step where you're actually writing sine inverse of sine of A. The only reason I put this here, I said to be purely formal, is because when you get to pre-calculus, you're going to be working with this, especially when you deal with trigonometric identities. I've seen this countless number of, I've seen this too many times, where students get really confused with this sine inverse of sine notation. And so I think it's kind of important to introduce this early on in like geometry. Once you see this and you get more comfortable with it, then pre-calculus, that section won't be so difficult when you start working with composition of trig functions and involving inverses. So that's important. So I'm just kind of, again, doing this formally, but when you're doing the work, you can skip from here to here if you want, although I think it'd be kind of useful, right, advantageous to write this part. Just to kind of get used to that, even though you won't see this again until pre-calculus, but still. Okay, so then this is our answer right here. All right? So that takes care of the second type of problem. So you've already seen the two kinds of problems. The ones where you need to solve for a missing side, and the ones where you need to solve for the missing angle. Okay? Now we're going to go ahead and look at word problems where we need to draw the picture. So sometimes that is a challenge in itself. So let's go ahead and look at question 6. So now we're doing one of these picture problems. So in question 6 we have, hold on, let me fix this. So we have basically a bus. Let me adjust this camera. So we have this kind of ramp with a right triangle, and then we have a bus right here in the picture. I'm not going to draw that. So the word problem is describing the situation. So this daredevil is building a ramp to attempt to jump his motorcycle over 35 school buses. The surface of the ramp will be 40 feet long. So the surface of the ramp, we're talking about this part. So this has to be 40 feet. So I'm going to go ahead and write that here, 40 feet. And the ramp must stand 11 feet tall. So this up here is 11 feet. So from the ground to the top. What angle will the ramp form with the ground? So again, the ground is this flat part, and we're talking about the ramp and the ground. So we're looking at this angle here. I'm going to write an X. So by looking at this, we can already identify that this is of the second type of problem, right? Where we don't know what the angle is, but we do know what the two sides are. So we could go ahead and use our trig ratios to set up an equation. So again, first we look at the angle, that's x. We look at the side that's relevant, which in this case is 11 on the opposite. So we have opposite. And then the 40 feet here, this represents the hypotenuse. So this is a case where you have opposite over hypotenuse. Let me write here, sine of x equals. Okay, so that's from our SOHCAHTOA. Now let's go ahead and plug in our numbers. So sine of x equals 11 feet. I'm not going to write the units there. Over hypotenuse, which is 40. This is the kind of problem where you need to solve for the angle. And to do that, we need to use our inverse trig functions. So sine inverse of sine of x Again, you don't have to write this particular step, but I think it's advantageous to kind of get used to this. That's that step. So the sine inverse and the sine cancel each other out, and we're left with the argument, which in this case is x. Whenever you hear me say argument, gotta be careful, because argument here means the input of the function. Of course, in geometry you also hear argument as in the set of reasons, right, to justify a theorem, or some proposition, some statement of some sort, which we'll call a theorem. Anyway, so just be careful with the kind of the two senses of argument. Alright, so here we get x equals. Now this part we can type in the calculator. So I'm going to show you how to do that here. So there's a calculator, so a second and then sine 11 divided by 40. Close the parentheses, hit enter, and we get 15.96. Now I believe we have to round this. Let's see, it doesn't say to round it to. Yeah, it doesn't give us a kind of a rule for rounding them, so we just have to find the one that is gonna be closest to it. So our answer is 15.962, and I'm rounding that here, so degrees. And then our answer actually has 16, so we're just gonna round it up to 16. So 16 degrees. All right. Let's say you do one like that. Okay. So question 7's kind of tricky. Right, so I'm going to have us just kind of set it up just to kind of understand the situation in the word problem. So it's saying that the citizen is walking along the street in New York City when she is 100 feet from the Empire State Building. Okay, let me start drawing that. So this is the Empire State Building. We'll call this here 100 feet. Okay. She looks up at an angle of elevation of 73 degrees. Okay, so new vocabulary. Angle of elevation. What in the world is that? So we're going to get two new terms here. Angle of elevation just means the angle that is formed from a horizontal but going up. Right, so if let's say, let me see if I can kind of do this with a pen. So let's say this represented the horizontal. So the angle that's formed by going up like that is called the angle of elevation. So we usually denote it the way I wrote it here. You usually have a straight line and then something going up, and then this guy right here is the angle of elevation. Now that we're talking about that, we can work with angle of depression, which is the other one. Kind of the other, one here and then two. Two new vocabulary words. Angle of depression. So again here, depression just means down. And the way this works is, well, you get a horizontal like that. Angle of depression just means the angle formed by going downward. So angle of elevation meant going upward. Angle of depression meant going downward. Okay. So this is kind of a side note here on just kind of vocabulary. Back to the problem. So it says that she looks up at an angle of elevation of 73 degrees. So that's going to look like that. 73 degrees. And sees a window washer hanging on the side of the building. So the window washer is up here. So I'll put like a dot there. Her eyes are 5 feet above the street. So that's important. So we're looking at her eyes here. So that means that the street is right here. So the distance from the ground to the street. So sorry, I'm not trying to be too ornate with my picture, but so here's the girl. Her eyes are 5 feet above the street, and she's looking at an angle of elevation of 73 degrees to the top of where the window washer is. Okay. So next, what are we going to do? Okay. To the nearest foot, how high is the window washer above the street? So we want to solve for this x, which represents this distance. Be very careful with that. X is the distance from the eye level, right, this horizontal, and the top. And the question's asking for how high the whole thing is, right? The window washer from the ground. Not from her eye level here, but from the ground. So once we solve for x, we need to add it to 5. Okay? So let's go ahead and do that. So let's start by solving for x. Now, to make this, I guess, a little bit more amicable, I can go ahead and draw the relevant information for the problem. So that's 100, this is 73, and this is x. And we can look at our angle and establish the kind of relationship, right, between the sides and the angle. So x is on the opposite side, so we have the opposite, so we have one to find. And then 100 is the adjacent. Remember, it's not the hypotenuse. Hypotenuse is along the side. It's the adjacent, so I'm going to put over 100. This is equal to, which one has an opposite and adjacent? TOA, which means tangent. So tangent of 73 degrees equals opposite, which in this case is just x, we're going to solve for it, over adjacent, which is 100. So now we can multiply both sides by 100 using our algebra skills. So it's saying 100 times tangent of 73 equals x. Now we can go to our calculator and plug it in. And then we get x equals 327. I'm going to round this to the nearest tenth, so that would be 0.1. Now don't forget, that's not the final answer. Is this multiple choice? Yeah, it is. Yeah, don't forget that's not the final answer. We still need to do one more thing. And be careful, because they do put that in the answer choices. They're trying to trick you. Remember, you want to find how high the window washer is from the ground all the way to the top, right? Not from her eye level to the top, from the ground to the top. So the last thing you need to do is 327.1 plus 5. Because you have to take into account these 5 feet here. Okay. So now here, the next one here, question 8, we have a radio tower and a guy wire. The guy wire is just kind of this thing here that represents in the problem the hypotenuse of the triangle. So it's this wire that attaches to the tower and then attaches to the ground like in a stake. Okay. So here it's talking about, let's see, they must install guy wires to support the tower in the wind. The guy wires must attach to the tower at a point 56 feet above the base of the tower. So that means that the wire needs to connect 56 feet above the ground, right? The base of the tower means the ground. That means that we know what this is right here. And it must form a 50-degree angle with the ground. So the wire itself needs to form a 50-degree angle here. And notice it's the wire, which is this guy. I'll write it here. Wire with the ground over here. Assuming that the tower is on ground level, how far from the base of the tower will the guy wire be secured to the ground? So it's saying how far from the base of the tower. So that means we're solving for this side, because this is representing the distance from the base of the tower all the way to where the guy wire is in the ground. Now we can use our trig ratios to solve for this. So we need to set up an equation. So our angle is 50 degrees. We have a side opposite. And then we have the adjacent. which one has O and A? It's TOA. So tangent of 50 degrees equals opposite, which is 56, over the adjacent, which is x. So here we have to be careful, because now the thing we're solving for, the x, is in the denominator. So what we need to do first is get the x out of the denominator. So multiply both sides by x so that we can remove it from the denominator of the fraction. Now I can rewrite what we have here. This is x times tangent of 50 degrees equals 56. Next thing we need to do is get the x by itself. That means we have to move the tangent of 50 to the other side. So we can divide by tangent of 50 degrees. Notice this whole thing is going together. Okay, we can't separate the tangent and the 50. This is part of the notation, it goes together. Okay, so now I'm going to write this part. This is x equals 56 over tangent of 50. And then we can type that in the calculator. I feel like you can't really see it here. Well, actually, I'll let you do that. You can type that in the calculator. And is there another one? I feel like I'm missing something. Oh yeah. Okay. So I'm going to kind of figure out how to set up question 9. So the city of Odessa, Texas is building a wheelchair ramp to make their courthouse accessible for persons in a wheelchair. The ADA requires that a wheelchair ramp have an angle of elevation of 4.8 degrees. So I'm going to go ahead and draw this with the ramp like that to make a right triangle. This angle of elevation from the ground to the ramp has to be 4.8 degrees. And it says the ADA guidelines also allow a maximum run of 30 feet of ramp before installing a rest platform. So max 30 feet for the actual ramp. If this, just be careful, let's interpret what this means. This is important, this part. What this is trying to say is if this ramp exceeds 30 feet, then we need to install a rest platform. So I'm going to write that on the side. If ramp is larger than 30 or more than 30 feet, then we need rest platform. And then the other situation is if it's less than or equal to, right? So if less than or equal to, I'll call the ramp R, I guess. If less than or equal to 30, then no platform, no rest platform. Okay. So we need to figure out, okay, well, we need to check, right, which one of these cases is it going to be, right? Well, so we use our trigonometry here. At the Odessa courthouse, the ramp must rise 2.5 feet to reach the top of the steps. That's this part, 2.5. So what we need to do is we need to use trigonometry to solve for the ramp itself and then check if we need to install the rest platform or not. So I'm going to write an X here representing the ramp, and we're going to set up this equation using our SOHCAHTOA. So here's our relevant angle. We look at the side opposite, which is 2.5, so this is opposite. And then we have the hypotenuse, so opposite and hypotenuse. So we're going to use SO. That means that we can write sine of 4.8 degrees equals opposite, which is 2.5, divided by hypotenuse, which is x. So again, we can use our algebra skills times x to get x out of the denominator. And then we can divide this by sine of 4.8 degrees. And then now this cancels, and all we're left with is x equals 2.5 divided by sine of 4.8, and I'll let you determine what that is. Of course, once you determine, you're going to tell me if we need the the rest platform or not. So we have to check what this number is. Is it equal to 30? Is it less than 30? Is it more than 30? And what does it mean? Okay. 10 is actually not as difficult as it seems. So it's talking about a bridal veil falls and blah 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 from the top of the 365-foot waterfall. So top of a waterfall. He looks down at an angle of depression of 27 degrees. So we're going to have to be careful. Remember what angle of depression meant. That was this, right? So I'm going to go ahead and use red to kind of draw that part, because that can be kind of weird. So let's do that here. So this is the auxiliary line. I'm just kind of drawing this in red because I want to make an important point about this. Hold on. So be careful. Go ahead and draw the triangle. Okay. Now the important point is a lot of students make the mistake of writing the angle of depression right here. That's actually wrong. The angle of depression really goes right here. Okay? If you look at the picture again, this angle of depression, notice it goes below this line, horizontal. And you might be wondering, if the angle of depression goes there, how in the world does that help us in solving this? Like, this just seems weird, right? Like, how does this help? Right, well, if we go back to our previous chapter on lines, well, one of the previous modules on parallel lines and transversals, we know that this angle here and the angle down here are alternate interior angles. It means this angle is 27 degrees. Okay, so that's why the angle of depression, sometimes teachers won't even draw this part, they'll just write it down here. And then you're wondering, hey, it looks like an angle of elevation. Well, yes, that's true, but just remember that it's the angle of depression from up here, from this part. The only reason it's the same over here is because this horizontal is parallel to the ground here. So this is the tricky step, okay, making sure you know what that angle of depression means, right? So we have our angle and we have this height of the waterfall. What are we trying to find? Well, it says here that he spots a bear fishing in the stream. How far is the bear from the base of the waterfall? So that's talking about this distance, from the base of the waterfall all the way to where he's looking at the bear at an angle of depression of 27 degrees. So this whole distance, we're going to call it x. We need to solve for it. So again, we're looking at this relevant angle, 27. This side over here is opposite. And then this side right here is adjacent. So I want you to tell me, so, ka, toa, which one of these are we using, and solve the equation. Alright, so set up your equation using one of these. Remember, we have opposite, we're looking for adjacent, that's a hint, opposite and adjacent. Right, we make an equation and then we solve for the adjacent, right? This is the one we want to find. Alright, so that concludes this video.